All good. Hey everyone, happy Friday afternoon. I'm Vinod Nannapaneni. I lead the cybersecurity architecture and engineering group for Equifax. And today I'm here to talk about architecting secure applications in cloud. It is a very dry subject compared to some of the fun topics you may be exploring, the red team versus blue team and whatnot. So um, I will leave it a little open-ended. I will, please do stop me whenever you want to in terms of questions. I also have no understanding in terms of the knowledge you already possess. So if this is already covering areas that you already know about, please do let me know and we can just skip past that subject.
Uh,
Any questions?
I will say there is probably a variety of like underclassmen and upperclassmen. So I
Okay.
think there's probably a good variety. And if you have a question, just raise your hand. I'll come and give you the mic. So feel free to just at any point, look without obviously interrupting. But yeah,
Okay. So how many of you have already worked in the cloud in terms of at least playing on by yourself in terms of whether it's AWS or GCP or Azure? Do any of you have any exposure to any of the cloud environments?
looks like a few.
Yeah.
Yeah, like pretty small, not a lot.
Okay. All right. So then what I can then do is make this a little more generic and not to talk too much cloud specific, but obviously we can uh, cover anything else if we need to. So fundamentally speaking, regardless whether it's your old school traditional data center based environments or if you're talking cloud, in the end, a, a generally secure application is considered to have three layers, three or more layers. The first layer in the is always referred to as a DMZ or an internet facing web tier. This is where you typically have your proxies, load balancers, your Apaches, Nginx, your web servers, right, that act as a front end to all the traffic that is coming in. And we do that because we do not want to obviously expose some of our sensitive assets directly into the perimeter. Folks who are probably trying to specialize in the red team side of things in terms of penetration testing will know the implications of having, let's say, sensitive systems exposed to internet. So that is something you do not want to do. And that's why you start off with non-sensitive systems in the internet tier, right? Right behind that is, now again, the first tier is always referred to as more of a public tier, right? And then you then have behind it two private tiers. The middle tier is where your actual business logic lies. This is where your application does the processing if you need to. And then you have eventually behind it an application tier, right? What your This architecture effectively allows us to isolate the most sensitive system, which is your database stores, away from public exposure, and you effectively have two layers before you can get to the third layer. This is generally considered the pattern for any enterprise level application implementation across the globe. This is an industry standard. This is what enterprise architects follow. This is what security architects follow. This is what you would see everywhere. There will be anomalies, but I don't want to go into that right now. The reason I bring up this architecture is everything that we talk from here on out will be based on this design. Everything in the world right now revolves around this three-layer design in a way, right? And one of the first items that you probably might have heard is the term defense in depth. It is to basically have more than one control protecting your asset. Um, I'll take a segue here. Quick question. Anyone have, does the term control ring a bell? Do you know what I'm referring to when I say control? Would you like me to elaborate on that?
Yes.
Yes? Okay. Uh, a control is, in essence, a defense mechanism, and you would always want more than one defense mechanism to protect your assets against attacks. One of the most common control or defense mechanism is on I would say your EDR, your antivirus on your machines. That's your first layer of defense at a machine level. And then you could then think of your firewall acting as, or your local router at home is acting as your second layer of defense, where it is probably stopping all the scanning happening over the internet that would otherwise affect your machine, right? Defense in depth is effectively ensuring that you have more than one layer of protective measures to ensure your systems are safe. The reason we do that is you always have to assume that one or more controls will or potentially fail at any given point of time. So if you had more than 2 or 3 controls, even if one of them was not working, for example, hey, my antivirus is out of date, it was not keeping up with, maybe you're using a free version of antivirus, and then, we're talking about a new virus variant that came out in the last month. The antivirus package does not know how to catch it. And should that actually get through the defense and onto the machine, it is definitely going to infect the machine. Again, I'm using a terrible example, but I hope you get the idea, right? So defense in depth is something that you would hear a lot. Generally, when we say outside coming in, again, from internet coming into your network, they're typically perimeter firewalls, network-related firewalls, server-related firewalls, and then eventually you have antivirus on the server itself, providing you that multiple layers of defense, hence the depth. The other thing you would see a lot, especially when you start working in the cloud, is the concept of a shared responsibility model. And very briefly, I would say this is where your AWS or Azure or Google Cloud, they own the infrastructure, they manage the infrastructure for you, they own the facilities, the data center, the racks, the network cabling and racking and all that, right? In that model, they own the physical responsibility of protecting the physical infrastructure, ensuring nobody can break into the data center, nobody can, physically plug into a server and try to copy the data, and so on. And from that point on, everything that we deploy in their cloud infrastructure then becomes our responsibility. Now, within that, there are 3 different layers, what we typically refer to as infrastructure as a service, platform as a service, and software as a service. For example, your Gmail is software as a service running on Google's infrastructure. And for software as a service, all you do is you open up your browser, you hit a URL, you are in that application, whether it's your Gmail or Google Chat or Google Calendar, right? Platform as a service is one level down, where you would get to write your code for your own application and you get to deploy it in certain scenarios. I'm trying to think of a couple of good examples. Have you heard of Lambda by AWS? On Amazon Web Services, Lambdas or Cloud Functions, any of those names ring a bell?
I don't know
Where
about. I think some people in the room have. Yeah, I have. I know with Lambda, it's like you essentially give them your code, and then they sort of will like scale it for you.
Exactly. So Lambda is the platform as a service where you don't have to worry about the operating system, the server, anything at all. You have a code, you deploy it, AWS runs it. The difference here between compared to the Gmail example is Gmail, the code is theirs. With platform as a service, the app code is yours, right? So you deploy your application there. The third layer, actually, I should have probably kept clicking this. So if you notice in the SaaS layer, the only thing we control is the data. That is your Gmail account. So your emails, your data, there's no other control. Whereas in platform as a service, you get to deploy your application and then you're interacting with the application and the data of the application. And the third category is infrastructure as a service. This is where you would deploy a virtual machine itself. It's like deploying with a full-blown machine with an operating system, and you do everything that you get to do. The key difference with infrastructure and platform as a service is with infrastructure, the operating system upkeep. If it's a Microsoft operating system, you have to make sure you're patching every month, keep up with the patch cycle, you make sure you have your antivirus and so on. So One of the reasons PaaS is beginning to pick up momentum, there's a lot of PaaS usage in the industry these days, is because you don't have to worry about patching and maintaining the underlying operating system. And the cloud provider, whether it's AWS or Google or Azure, they do the management of the operating system for you. Any questions so far?
I do not think so.
All right. We will then move on to some more foundational concepts. One of the ones I would say is the identity and access management. Everything in cloud revolves around IAM. IAM is the first line of defense. IAM is the last line of defense. Whether it's the pen testers trying to break into their environment, somebody's environment, they would be trying to leverage IAM models. Most of the attacks these days are IAM based. The Capital One incident that happened 4 years ago was related to IAM. Misconfigurations around assets is also related to IAM. So if there is one area that you could really benefit with good knowledge is IAM, right? You would also hear concepts like zero trust that show up in the same area. The idea of zero trust is to ensure that you don't trust any session at all, and that every session has to uniquely identify itself before it is granted access to do any activity. And the least privilege also goes along with IAM, right? Do not give users more permissions than they need to. Keep the permission levels minimal for their required job function. Any excessive privileges can eventually lead to loss of data should the privileges be abused or if the identity is compromised. Yeah, the IAM account is compromised. You probably heard enough about the industry recommendations about having MFA enabled. MFA is one of the core tenets these days for every single application and capability out there, whether it's SMS-based authentication or using a app which generates a random 6-digit code. MFA is the one way to ensure the app accounts are kept safe. Depending on your exposure around cloud IAM, I can skip past the temporary credentials and actually move on to the secure network design. Any questions so far?
I don't think so, no.
Okay. Is the content resonating or am I really off target?
No, I think I don't know about everyone else, but I mean I see some nods. I think it's interesting. I have like
Okay.
some familiarity with cloud, but it's definitely good to sort of get like more of a basis than I already have.
And I do have to say the architecture and engineering practice in the cloud, especially around cyber architecture engineering, tends to be a little more drier compared to your typical red teamers or blue teamers trying to look at logs or trying to execute pen tests. This is something that folks generally transition to once they've worked in a specific area for a few years. So once you start working, you don't get to become a cloud architect on day one, right? So I'm sure if you would like me to cover a different subject, I can come back with a different area, and I'm just putting options on the table for you folks. Yeah.
For sure, I appreciate it. I mean, I will ask actually, like, do you
Yeah.
enjoy then working like as a cloud
I
architect?
absolutely love this. I've been doing this for over 15 years. I've actually started my career as a Java programmer about 20 years ago. I did not like Java programming, so I ended up becoming a Unix administrator.
That's fair
Uh,
enough.
right. And from that point on, I transitioned to becoming an IT architect. Back in the day, we used to rack and stack and cable the networks and servers ourselves. So we had a little bit of more understanding of how the network architecture worked. And from that point on, I kind of transitioned into architect and eventually becoming a cyber architect and now leading the teams around architecture and engineering. So I would generally say as long as the fundamentals around ports and protocols and the tools around how HTTP works, right? How FTP works, right? And if that knowledge is gained at the stage where you're in, you will have many opportunities to transition into any role you would like on the cybersecurity side. Cyber is one of the areas where you could be a pen tester today and transition to, let's say, a blue team acting on the defense side of things, looking at logs in a span of 2 years. The knowledge you gain in one domain will act as like a significant strength in another domain. That being said, I know I'm reading a little bit of the content I'm supposed to present, but if you guys would rather talk about everything more generically, I'm happy to do that as well.
No, no worries. I think everyone here is interested in like literally anything cybersecurity related. So
Okay. Yeah, so one of the things that we do typically is to ensure the fundamental network design is secure, because along with IAM, network plays a key role. And when applications are deployed in the cloud, we do ensure that we enforce appropriate segmentation. Going back to the concept of public and private, great care is taken to ensure all the assets are deployed only in like a non-internet exposed private segment, and only the applications that need internet exposure are deployed into the public subnet, and that too by using proxies or load balancers. Yeah. And then, yeah, obviously make sure we're configuring the firewalls to only allow the required ports and nothing more than what is needed. The other thing you will hear in the industry a lot is around DevOps or DevSecOps. There's not fundamentally not much difference, and security has also adopted DevOps. And that's where DevSecOps comes into play, where now security is deployed as code. So going back to the earlier example, if somebody were to deploy a Lambda to run a web application, the code protecting the Lambda in terms of the configuration itself is also packaged as part of the Lambda code and deployed together in production at the same time. So having a strong understanding on DevOps will also help gain an understanding how security would package into DevSecOps and deliver secure applications in cloud. And yes, encrypt everywhere. Make sure the data is encrypted at rest, encryption in transit, everything over, you probably know, use only HTTPS. Do not use HTTP because HTTP is susceptible to man in the middle, and you want to ensure you're visiting and communicating traffic only on encrypted protocols. How many of you have exposure to secrets, and do you know what secrets mean, and why do we need to protect secrets securely?
like
If
everything
you
like 50-50 maybe.
Okay. So when you develop an application, that application very likely has to interact with the database, and the database most of the times would have a username and a password. And current practice is generally to include, not current, we always historically used to include the username and password in a configuration file and just deploy it on the web server along with the code. And anybody who could get to that web server could then access that config file and then go exploit the database. It is for that reason, it is strongly recommended not to store any sensitive information that could lead to a bigger compromise in configuration files and in plain text. And that is where secret managers come into play. Now, within each cloud, there are secret managers that are provided. Google has their own secret manager. They call it KMS. AWS also has a KMS, in turn also referred to as a key management service. This is where you put in your secrets, and at runtime, when the application needs to access the database, it retrieves the credentials from the secret manager and connects to the database. That way, the application does not know what the secret is ahead of time, and only folks who have access to the secret manager know ahead of time. And that can then be limited to 1 or 2 people, because you don't need to share the key broadly. You don't need to put in a config file. None of the developers can see it. None of the admins can see it. It is definitely one of the ways to ensure that the key to the database is kept secure. And lastly, I think I probably have 6 more minutes here.
I mean, you can go like as long as you want. There's plenty of time after as well.
Okay.
No rush.
So once the application is deployed, and I think this is the part where it might really intrigue you guys, we tend to have, every enterprise tends to have a dedicated security monitoring team, right? And within that security monitoring, there are different layers. You have your typical SOC, Security Operations Center, which is generally shift-based. You have 24/7 coverage in that SOC, and their only job is to monitor for events, protect the enterprise against threats. And once the SOC gets an alert and they do their initial triage, and once they confirm that it is indeed an event, they typically engage the incident response team. And that's when the incident response team actually does another round of review, and if it is a valid incident, they then just initiate the incident response protocols. The reason I'm giving that background is, in the end, in cloud, everything revolves around logs. We today consume around 20 to 30 terabytes of logs a day, and that is not including logs that we put into cold storage. And if I were to translate that into billions, I'm talking somewhere around 10 to 15 billion log rows per day in terms of the volume, right? And our systems then comb through, and this is where you probably heard of some of the industry products like Splunk and Azure Sentinel, and this is where the dedicated SIEM products come into play, where these logs are then fed into the SIEM, and that is where your cyber analysts then start writing detections around specific threats. Those detections, when a particular event is found, and when I say event, I'm really referring to an anomaly where, again, if I were to use a simplistic example, you do not want to see a user that does not belong to a company show up in one of the logs, for example, right? Those events then trigger to SOC, and then from that point on, the protocol follows. As I said, logging is, if anything, the only and one of the fundamental detective controls or detective capabilities that are provided in cloud, and it is like immensely helpful. It is actually, it is required, and in some cases, it is even obligated by federal requirements, depending on which regulated industry you're operating out of. Financial services, it is an absolute mandate that we do a certain level of logging. And I would say that is one of the reasons probably our logging levels are so high. As I said, we process almost 20 to 30 terabytes on any given day from a volume standpoint. And we have a team of about 50 analysts across 3 countries. And I would actually say three different time zones to ensure 24/7 coverage. In terms of watching the platform, if you will, and then responding to any incidents. And 99% of the times, the alerts are false positive, where should an actor get through, and when we say actor, it could really be a benign virus, right? That is where you're going back to my earlier comment around defense in depth. If the malware defenses are working properly, if the antivirus is up to date, it is working properly, it will act on it. It will merely throw an alert that, hey, I found a suspicious file. I took care of it. You don't have to do anything else. And even that, in the end, is a log record, because in the end, we're talking about 30 to 40,000 servers, and we're effectively talking about 30 to 40 people protecting those 50,000 servers. So the protection measures have to work at scale, and that is where the defense in depth combined with having appropriate monitoring protections is key. And that's the example I was referring to in terms of automation. Given the limited capacity that we have in terms of the personnel, there is no way we can tend to each and every alert that is generated on any given day when we get hundreds of alerts. And the automation around, especially with the AI, things have become, I would say AI has begun to play a big role in the cyber analyst space as well, where we proactively feed alerts into AI engines to look for anomalies. And if the alert is indeed a false positive or a true event that we need to act upon, and based on the response, we either auto remediate or auto close the incident, right? And lastly, should in an unforeseen scenario it be an actual incident, we will always have playbooks. That's what's referred to as a step-by-step plan to execute upon should there be an actual incident. And I think generally when an incident happens, those are very high pressure scenarios. There's a lot of stress involved for people who are actively working on the incident. And the one way to ensure that the appropriate steps are followed is to ensure that the process is well documented. And I would say I went through everything at a very high level. If there are areas that really appeal to you folks, I can always come back with a specific targeted conversation. But if you have any questions, please do ask.
I'll start just with some questions.
Yeah.
Just like if just like with the point that you were just on with incidents, I mean, is that something that you guys like go through a lot? Like, do incidents occur a lot, or is that like a like not that common thing that occurs?
Well, the definition of incident, I do want to clarify that, right? Then, do we have an actual incident? No. But do we have alerts that require us to validate whether it's an incident or not? We get a ton every day. Yes.
And also, like, can I ask a more like general question for like Equifax in general?
Sure.
So like with like the scale of the company and like all of the information that you guys deal with, are there a lot of like compliance standards that you have to meet that are like very strict?
Yes. Yes. So we do process credit card information. So we are obligated to meet the PCI DSS standards, right? For folks who sign up for, I would say, you want to look up your own credit score, you're putting in your credit card information to look up your scores. We process credit card information. So we do have to meet PCI DSS. Uh, New York State requires us to meet New York Financial Services Compliance Requirements. It's referred to as NYDFS. We have to meet that to do business in New York. We are required to meet SOX, which is the Sarbanes-Oxley for financial services firms. We have our own SOC 2, type 2 for our general infrastructure. So I would say, yeah, we do have quite a few compliance frameworks, including a framework from FTC, the Federal Trade Commission.
And like, do you think that like that directly affects like the architecture that you like develop and like your job, like compared to a company that would say like doesn't handle information like that? Is there a massive difference, would you say?
100%. A startup doesn't have to worry about all this.
And so like,
Absolutely.
sorry, go on.
No, I was going to say that 100%. The business and the requirements around the compliance dictate the measures we have to take to protect those assets. Yeah.
Okay, if anyone else has any other questions, feel free to raise your hand and I'll come and give you the mic. If not, I'll ask another question as well. Okay.
Hello, hey Vinod. That's how you pronounce
Hey,
it, correct?
you good? Yep.
Okay, okay. Great presentation. We're holding our applause till the end. I had a question about, I guess, the like software as a service, infrastructure as a service. There are
Sure.
different models, and essentially there's some sort of like shared responsibility between the provider and the companies that are actually using this
Correct.
software or infrastructure, correct?
Yep.
Um, if so, if there's like some sort of vulnerability or incident, if it's like an real incident, where's that line drawn where like who does the brunt of the work, I guess, to trying
Yeah.
to remediate some of those issues?
Yeah. So depends on where the incident happened. So obviously, before we use a cloud provider, we do sign appropriate contracts, right? The indemnity clauses and so on. But let's say if the incident happened at a physical layer where somebody managed to actually get into the data center and hooked up their USB port and copied data out, that would completely be the responsibility of the cloud provider to remediate, notify the consumers who were affected, whoever's data was on that server at that point. They have to notify the customers and they will bear the brunt of the remediation. Now, on the contrary, if it has happened in one of our applications that we are running, that is on us and not the underlying cloud provider.
All right, thank you. Any other questions? I'm sure you can ask like anything. It doesn't need to be hyper specific. Yes? Well, okay, yeah. What are some tools or like resources that you'd recommend if if someone is interested in getting into cloud?
Nothing beats your own keyword. It's AWS accounts are free to sign up. Get your parents' credit card and play. I mean, really, a Linux machine in AWS is less than $100 a month. But you get to play and explore. The hands-on knowledge, nothing beats that. And if you're looking for resources to help you understand what you do and how you go about, I mean, I'm not recommending, but some of the tools that I know, some of our early entry engineers use are, I believe, Code Academy is one. There are plenty, I would say, YouTube resources as well that let you just navigate your way into cloud, and nothing beats. You can sign up for an account for free. There's no cost to signing up an account and just poking around and just looking at things. Just make sure you're not downloading malware because you would end up getting a call from one of the cloud providers' technical support teams. Because the
And
agreement with any of the cloud providers is to not misuse their resources. So as long as you're not attempting to do something terrible, you would be fine.
gotcha. Any other questions? I saw a hand up over here. Maybe. Okay, I guess I'll ask another question. So like over the past years, have you seen like a major shift in like how long have you been at Equifax?
I've been with Equifax 4.5 years.
Okay, I guess I don't know how long that like time frame is with cloud, but have you seen like a shift towards using a lot more like cloud as infrastructure?
Um, the transition to cloud as infrastructure happened 10 years ago.
Yeah, so I don't know if that's
We are now at an inflection point of moving to AI in cloud too. So there are not many firms that are still using the legacy on-premises systems. It's far and few. Many of the large enterprises have cloud footprint in one way or the other. And I would definitely emphasize the need to upskilling in cloud as the path to future and mix that up with AI for sure.
also with like that like gaining prevalence with AI. Do you see that like affecting cybersecurity jobs? Isn't like the job market in general, or like how people conduct their jobs?
Yeah, absolutely. For example, this presentation I created in Gemini because I'm not good at slides. So Um, so is it everybody? I'm really talking about, okay, I'll give you a great example. Pen testing, right? Back in the day, not when I say back in the day, I'm still talking 6 months ago, when pen testers have to go perform a test against an asset, they typically used to perform an effort. It's called the reconnaissance effort, where they go, you scope an asset and the environment, the footprint, the ports, protocols, you don't need to spend time trying to recon anymore. There are plenty of AI tools where you can just tell it to go do recon for you, initiate attacks for you. It'll do everything and it'll generate the report for you. So I think it's absolutely vital that especially as upcoming grads, you embrace AI wherever you can and look at it as your I shouldn't say peer, like your assistant. You have to adopt using AI as your assistant. We are using AI big time already, both in our defense approach as well. Like we've automated all level 1 analyst roles to AI, where the AI looks at an alert, does the initial sequence of steps to see whether something is really false positive or not. And if it is, it then bumps up the ticket to level 2. That's already happening.
That's pretty crazy to think about. Do you think
Mhm.
that like AI could ever do your job or like a solutions architect at some point? Do you think that's possible?
I think it's getting close. It potentially could. Because as I said, I just had to type in the appropriate prompts for it to generate some recommended architectures and best practices, and here you go. This is everything AI generated.
Is that something that like you're worried about in the future, or like at least
No,
no?
no. But so that is where I would say the experience aspect of ours comes in. As much as AI can do, it cannot replace human experience. So this is why I would say as long as we start adopting AI as our assistant and use that to improve our own productivity and our own pace and skills, you will be golden.
Okay, thank you. Any other questions? Okay, question over here.
Yep.
Do you ever worry that perhaps like you said that you're automating all the level one analyst positions? Do you think that there's going to be like maybe in like 10 years there's not going to be anyone to like move up to like more of a senior role because there's going to be less junior analysts being hired right now?
That is a great question. I do not have an answer to right now. It is definitely becoming a struggle for junior analysts. I can see that in the market. It is already materializing. But the difference, however, I would say is the one thing I would emphasize is the junior analysts that are also graduating right now and are trying to look for jobs do not have or have not adopted some of this AI transition that has happened in the last year or two, right? And as long as you figure out a way to supplement those skills, I think you'll be fine because all companies that are looking for junior analysts, if I were to have two analysts, one without AI exposure and one who can actually use some sort of an AI capability to deliver things quickly, I would be leaning towards hiring that second candidate and not the first. I do not know if that answers your question.
Yeah, it is kind of difficult. I'm here. Do you want to?
Yeah, that answers my question to a sufficient extent.
Yeah.
Yeah, I definitely agree that. I mean, I don't know what your experience, but I feel like that is kind of hard to know exactly what things will look like because AI has changed so much. Like every month, there's
Right.
a new development, pretty much.
Yes. But fundamentally, what has not changed is the ability to use that as a supporting mechanism to do your function better.
Yeah, for sure. Any other questions? Okay, I think that's everyone then. All right. Well, I thank you again for coming. I really appreciate it.
Of course. And I do want to say that, oh, please, no need for an applause. No,
Okay,
thank
no,
you.
give him an applause.
No, I do want to say, no, thank you. I do want to say if you have any questions about the vulnerability management, cyber analyst side, pen testing, and um, security advisory, I do have exposure to multiple domains. I'm more than happy to come talk to you guys more, if not anything else, just in terms of what does it mean specializing in an area that you might be wanting to. If you don't know what you want to specialize in, but you are in cyber and you're trying to figure out where to go, please, I'll be happy to help.
For sure, we really appreciate it. We can probably figure out in like another time next semester. I think people would be interested. Like, I know there's a lot of red team interest, blue team as well. So stuff like that, I'm sure people would be interested in hearing about.
Yeah. Well, talking about that, there's also purple team. I don't know how many of you have heard of purple teams.
Yeah, I think so. We have.
Yeah.
I don't know if we
Okay.
have it this semester, but last year we had a competition that did have some purple teaming on it.
Oh, there you go. All right.
All right. Thank you again for coming.
All right. Thank you. I'll have a good Friday.
You too.